So today we are going to discuss about edible fats and oils, their classification and chemical composition. Lipids are naturally existing broad group of molecules which includes fats, waxes, sterols, fat-soluble vitamins, all of them, A, D, E, and K, triglyceride, diglycerides, monoglycerides, and phospholipids. Lipids are very well known for their pronounced hydrophobicity. Because of that, you know very nicely that it is exclusively soluble in organic solvent only and not in water. You know that lipids are obtained from all sources like vegetables, as vegetable oils, cocoa butter, etc. From animal source as of milk fat, lard, tallow, etc. and marine sources like whale oil, cod liver oil, etc. These play a very important role in nutrition as well as physiological functions because it is a rich source of energy and provides 9 kilocalorie per gram. And it is also a source of essential fatty acids and various fat-soluble vitamins. Some lipids are amphiphilic in nature, that is, they contain both hydrophilic and hydrophobic groups with surface active properties. Fats enrich the nutritional quality and impart the desired body and texture, rich mouth feel to the food. They also provide characteristic flavor to food and produces a feeling of satiety or loss of hunger. Now we will discuss about classification of lipids. This classification can be done on several bases in three groups. That is based on first is complexity or their structure, second is saponification process, and third is based on polarity. Based on structure or complexity, lipids can be classified into three groups, that is simple, complex, and derived lipids. Simple lipids are composed of fatty acids and alcohol components and include fats, oils, and wax esters. They can be hydrolyzed to two different components, usually an alcohol and an acid. Compound lipids include glycerophospholipids, glyceroglycolipids, and sphingolipids. On hydrolysis, naturally, it will yield three or more different compounds, which are their components. Derived lipids meet the definition of a lipid, but are not simple or compound lipids and include fatty acids and alcohols, which are the building blocks for the simple and complex lipids. It also includes sterols, vitamins, pigments, hydrocarbon, etc. Next is based on saponification. Based on the ability of lipids to react with alkali to form soap. Based on this reaction, lipids are grouped as saponifiable lipids and unsaponifiable lipids. Saponifiable lipids react with alkali to form soap. It is present in large amount. Its example include glycerides, phospholipids, fatty acids, cholesterol, ester, etc. And unsaponifiable lipids do not react with alkali to form soap. They are naturally present in relatively small amounts, and examples belonging to this group include fat-soluble vitamins, sterols, hydrocarbons, carbonyls, etc. Next classification is based on polarity. In this group, lipids are classified into two groups, that is polar lipids and non-polar lipids. Polar lipids are charged molecules which is soluble in polar solvents like alcohol, acetone, etc. For example, phospholipids, glyceroglycolipids, fatty acids, etc. Non-polar lipids are uncharged molecules which is soluble in non-polar solvents like ether, benzene, hexane, etc. And examples are glycerides, sterols, sterol esters, carotenoids, waxes, vitamins, etc. Now there is different type of classification which is known as traditional classification of edible fats and oils. This is based on source of fats and oils and the constituent fatty acids present in them. First is milk fat. They are derived from milk of mammals, particularly from buffalo, cow, goat, and sheep. Major fatty acids of milk fat are palmitic, stearic, and oleic acid. They contain appreciable amounts of short-chain fatty acids. Butyric acid is a characteristic fatty acid of milk fat. Next group is lauryl or lauric acid. This has characteristic fatty acid of lauric acid, which is almost 40 to 50% of the total fatty acids. Low amount of unsaturated fatty acids and thus having low melting points. It contains moderate amount of C6, C8, and C10 fatty acids. These are obtained from certain species of palm, for example, coconut oil. Third group is vegetable butters, obtained from the seeds of various tropical trees, for example, cocoa, characterized by their narrow melting point that is due to arrangement of fatty acids in the triglyceride molecule. It is widely used in the manufacture of confectionery products, for example, chocolates, etc. Next group consists of oleic and linoleic acid fats. These are fat present in vegetable origin mostly, contain large amounts of oleic and linoleic acids, contain less amount of saturated fatty acids, that is less than 20%. Cottonseed, corn, peanut, sunflower, palm, olive, and sesame oil are important examples of this group. Next group is linolenic acid fats, which contain large amount of linolenic acid, soybean, rapeseed, wheat germ, hemp seed, soybean being the most important in this group. Linolenic acid in soybean oil is responsible for off flavor, that is flavor reversion problem is because of that linolenic acid in soybean. Next group is of animal body fats. It is known as depot fats from domestic land animals, for example, lard and tallow. They contain large amount of C6 and C18 fatty acids. They contain medium amounts of unsaturated fatty acids, mostly C18-1 and C18-2. They contain appreciable amounts of saturated triacyl glycerols and shows high melting points. Egg lipids are important due to their emulsifying properties and high content of cholesterol. Next and last group is of marine oils. They contain large amounts of omega-3 polyunsaturated fatty acids with up to 6 double bonds, and they are very rich in vitamin A and D. Now here this table shows the gross chemical composition of fats of various species. Here you can see that there is hardly any difference between triglyceride content of buffalo milk fat and human milk fat, and cow milk fat has minimum amount of triacyl glycerols, whereas maximum amount of diacyl glycerols is contained by human milk fat. Monoacyl glycerol is present in very trace amount in human milk fat. Again, cholesterol level is highest in cow milk fat. Cholesterol esters are also present in very trace amount in all these fats. Phospholipid content is maximum in cow milk fat, that is 0.6. And free fatty acid content is minimum in cow milk fat. Now we will discuss about unsaponifiable matter of various fats and oils. As we have discussed about classification based on saponification, which is defined as the number of milligram of potassium hydroxide required to saponify 1 gram of fat. Saponification value is related to molecular weight of the constituent fatty acids in a particular fat. Fats and oils contain an average of 0.2 to 1.5 of unsaponifiable compounds. Here you can see the saponification reaction where triacylglycerol reacts with 3 molecules of potassium hydroxide and it gives free glycerol along with soap. The unsaponifiable fraction of fats consists of sterols, terpenic alcohol, aliphatic alcohols, squalene, and hydrocarbons. In most fats, the major components of the unsaponifiable fraction are sterols. Animal fats contain cholesterol, and plant fats and oils contain phytosterol, and they have no or only trace amount of cholesterol. Predominant phytosterol in plant fats include 3-cytosterol, and other phytosterols include campesterol and stigmasterol. Sterols are compounds containing the perhydrocyclopentenophyllanthine nucleus, which they have in common with many other natural compounds, including bile acids, hormones, and vitamin D. Sterols provide a method of distinguishing between animal and vegetable fats by means of their acetates. Cholesterol acetate has a melting point of 114 degrees centigrade, whereas phytosterol acetates present in plant sources melt in the range of 126 to 137 degrees centigrade. And this provides a way to detect adulteration of animal fats with vegetable fats. Now, let us see various constituents present in unsaponifiable matter of lipids. First constituent and most important constituent of unsaponifiable matter of lipids is hydrocarbons. Edible oils contain hydrocarbons with an even or odd carbon number ranging from C11 to C35. Olive, rice, and fish oils are very rich in this class of compounds. Olive oil and rice oil contains mainly linear triterpene, which is known as squalene, having 30 carbon atom. This compound is used as analytical indicator for the olive oil. It is also present in substantially high amount in fish liver oil. Second constituent includes sterols. These compounds contain perhydrocyclopentenophyllanthine tree nucleus. The steroid skeleton contains 4 condensed rings, that is A, B, C, and D. A characteristic in steroid is presence of an alcoholic group in position 3. In most of the fats, major component of unsaponifiable fraction is sterols. In animal fats, mainly it is cholesterol, and in plant fats, it is phytosterol. Prominent phytosterol is beta-cytosterol. Cholesterols are obtained biosynthetically from squalene, as we have already studied it previously in previous slides. In animals, cholesterol is the precursor for the biosynthesis of steroids and bile acids. Polycalciferol, vitamin D3 is formed by the photolysis of 7-dehydrocholesterol. Main steroid of yeast is ergosterol, that is provitamin D2, which is converted by irradiation into ergocalciferol, that is vitamin D2. Third constituent is tocopherols or tocotrienols. Methyl derivatives of tocol are denoted as tocopherols. Some methyl derivatives of tocotrienols are also found in foods. Alpha tocopherol is most abundant tocopherol having greatest biological activity and it is very important in foods, as it is also having antioxidant property in foods which is containing fats and oils. Next constituent is carotenoids. Polyene hydrocarbons biosynthesized from 8 isoprene units and have 40 carbons. These provide the intensive yellow, orange, or red color to a great number of foods of plant origin. They are synthesized only by plants and reach animal tissues via the feed and can be modified and deposited there. Carotenoids are divided into two classes, that is, carotenes and xanthophylls. Carotenes are pure polyene hydrocarbons, and xanthophylls have oxygen in the form of hydroxy, epoxy, or oxo groups and are present in corn, green leaves, egg yolk, etc. Now, in this table, we can see composition of various unsaponifiable matter of some fats and oils. And here, you can see that olive oil contains, in case of hydrocarbon, it is present in maximum amount in lard. Regarding squalene, amount of squalene is maximum in case of olive oil, that is ranging from 32 to 50. Regarding aliphatic alcohol, it is present in maximum amount in rapeseed oil. Terpenic alcohol is also present in maximum amount in linseed oil, whereas sterols are available in maximum amount in corn oil. That is all about unsaponifiable matter of some fats and oils. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Hello.